Okay, today we'll start second part of probability. First of all, conditional probability. Condition applied in probability. Let A and B be two events of simple sample space S, and let probability B not equal to 0. That means this will be not happen. Probability B will not happen. That means probability of B equal to 0. Then the conditional probability of the events A given B denoted by probability of A when B happened. This is the probability uh, when B condition. There is a condition in this probability A by B. And when B happened, then probability of A when B happened. This is read as probability of A when B is happened is defined by probability of A when B is happened equals to probability of A intersection B divided by probability of B. Actually, this is the conditional probability in mathematical way. Probability of A when B is happened. If B is happened, then the probability of A will be probability of A by B. This equals to probability of A and B happened in a body A and B divided by probability of B. We have to prove a theorem according to the conditional probability. If the events A and B defined on a simple space S of a random experiment uh, are independent, then probability of A when B is happened equal to probability of A, and probability of B when A is happened equals to probability of B. We have to prove this theorem. You must remember that probability of A when B is happened. Probability of A when B is happened equal to probability of A, and probability of B when A is happened, then probability of equal to probability of B. Hmm. Now prove A and B are given to independent events, individual events. Then probability of A and B. That means probability of A intersection B equals to probability of A multiply probability of B. We get from multiplicative law of probability. This imply probability of A when B is happened. B ঘটলে A ঘটার সম্ভাবনা. Probability of A when B is happened equals to probability of A intersection B divided by probability of B. This is from conditional probability. This is the condition. Equal to this probability of A intersection B equals to what? Probability of A into probability of B, and is used for only intersection. Remember it. Probability of A into probability of B divided by probability of B. This is this cut, probability of B cut. This equals to probability of A. That means probability of A when B is happened equals to probability of A. A ঘটলে B ঘটলে A ঘটার সম্ভাবনা. Probability of A when B is happened. Similarly, probability of B when A is happened, probability of A B intersection A divided by probability of A. Then probability of B intersection A means what? Probability of B into probability of A. Probability of A cut, then equals to probability of B. That means we get probability of B when A is happened. A ঘটলে B ঘটার সম্ভাবনা equals to probability of B. Clear? Now, most important theorem, bias theorem in probability. Try to understand. If B1, B2, B3 dot dot Bn are mutually exclusive events with probability of Bi not equal to 0, that means this probability non-zero. That means this probability must happen where I equals to 1 to dot dot up to n of a random experiments. Then for any arbitrary events, another events A of the sample space of the above experiment with probability of A must non-zero. That means greater than 0. Then we have probability of Bi. That means I times events here. I times events of probability B. Probability of Bi when A is happened. This equals to probability of Bi multiplied probability of A when Bi happened divided by all the probability of Bi and probability of A when Bi is happened, this whole sum. We have to divide with the whole sum. Summation I equals to 1 to n probability of Bi into probability of A when Bi is happened. That means probability of B2 if I equals to for n equals to 3. This is for n equals to 3. When n equals to 2, that means I equals to 2. We have to put I equals to 2 here. Probability of B2 when A is happened equals to probability of B2 divided into probability of A when B2 is happened divided by I equals to 1 to n. That means I equals to 1 to 2. Then probability of B1, probability of A by B1 plus probability of B2, A by B2, probability of B3, A by 3 when n equals to 3. This is the statement of Bayes theorem. Now, let S be the sample space of the random experiment. Then events B1, B2 dot dot up to Bn events being exhaustive. That means whole S equals to B1 union B2 union dot dot up to union Bn, and A equals to A intersection S. A intersection S since this whole S will be happened when A is happened. This is why this is the conjugate events. A equals to, we can write A intersection S, and A intersection S means what? B1 up to Bn. This is S. A intersection B1 union A intersection B2 A intersection B3 dot dot up to union A intersection Bn. We can write this. Now the probability of A equals to probability of A. If we take the probability of this A, then probability of this plus this plus this plus up to n times probability of A intersection Bn. And probability of A intersection B1 from multiplicative law, from multiplication law, we can write probability of A intersection B1 equals to what? Probability of B1 divided by probability of A by B1 plus B2 divided B2 into probability of A B2 plus dot dot probability of Bn equal to probability of A when Bn is happened. That means B1 probability of B1 when B1 is happened, probability of A when B1 is happened, probability of B2 into probability of A when B2 is happened, plus dot dot up to probability of Bn when probability of A when Bn is happened. We can take this series up to n times I equals to 1 to n probability of Bi, probability of A when Bi is happened. This is equation number 1. Now probability of A intersection Bi equals to what? From multiplicative law, probability of A into probability of Bi when A is happened, right? And now if we take this value, probability of Bi when A is happened equal to, then this divided by probability of A, right? Probability of Bi when A is happened equals to this probability of A intersection Bi divided by probability of A. This means from equation 1, this series, and A intersection Bi equals to what? Probability of Bi multiply probability of A divided by Bi. That means probability of A when Bi is happened. This is the proof of the Bayes theorem. Different kinds of application in engineering, especially in industry, in uh, different area, we have to use this Bayes theorem. In next example, we will see this, the application of this Bayes theorem. Suppose this example, an urn I contains 3 white and 4 red balls, and another urn 2 contains 5 white and 6 red balls. That means there are 2 urns. One ball is drawn at random from one of the arm and is found to be white. That means one ball is drawn at random from one of the arm and is found to be white. Find the probability that it was drawn from arm 1. We have to find out the probability that it was drawn from 1. Suppose U1 is the first arm and U2 is the second arm, and W be the ball which is white. W is for white. Now we have to find out probability of first urn, eh, probability of white ball drawn from first urn when if it is white ball. That means there is a condition applied here. Uh, if the ball is white, then what is the probability of probability that it was drawn from urn 1? That means probability of drawn from urn 1 when it is white. Understand this? We have to find out this. Now by the Bayes theorem, we know probability of U1 when it is white ball equal to probability of U1, probability of white when it is urn 1 divided by summation probability of U1 P W probability of white when it was in first urn plus probability of U2 when it was drawn from urn 2. That means we have to use Bayes theorem for I equals to what? 2. For n equals to 2. We have to use this theorem. Just second term, up to second term, we have to use n equals to 2 and n equals to 3, n equals to 3, b2 divided by a. That means probability of a when b2 is probability of b2 when a is happened. We have to use this series, Bayes theorem series. Now by the Bayes theorem, we can write this just u1 for first term, and if it is white, then the probability is this. Since two urns are equally likely to be selected, so the probability of selection urn, probability of selection urn, probability of u1 equals to probability of u2. That means half, right? Since this is there are two urn and first urn, we have selected first urn. This is why the outcome, the favorable outcome will be 1, and the total urn what 2. This is why the probability of selecting any one urn will be 1 by 2. Now probability of white ball when it comes from first urn equals to probability of a white ball is drawn from urn 1 equals to 3 by 7. Why 3 by 7? There are how many white ball? How many white ball in question? 3 white ball. And total ball what in first turn? 7. This is why 3 by 7 probability. Another probability of white ball when it comes from second urn equals to probability of a white ball is drawn from second urn equals to in second urn white ball how many? 5, and total ball will be 11. This is why the probability is favorable space sample divided by total sample 5 by 11. Now from equation 1, just putting the values, probability of coming from first turn when it is white ball equals to just value putting from here. Probability of u1 equals to half. Then probability of w by u1 when u1 is equal to 3 by 7. Then probability of u1 half. Then probability of w when it is comes from first turn 3 by 7 plus probability of second urn half, and probability of white ball when it comes from second urn 5 by 11. This is the result. Three urn contains 6 red, 4 black, 4 red, 6 black, and 5 red, 5 black balls respectively. There are 3 urns. One of the urn is selected at random. A ball is drawn from it. If the ball is drawn from as red, then find the probability that it is drawn from the first urn. First urn, it comes from first urn. We have the probability of that. Find out that. Now let u1 be the first urn, u2 will be the second urn, then u3 will be the third urn. We have to draw on a ball. R be the red ball. R be the ball of red. Now we have to find out the probability of the ball drawn from first turn when it is red. If the ball is red, this is the probability we have to find out. Now by the Bayes theorem, probability of u1 by r when r is happened, then means if r it is r red ball, then it comes from the first turn equals to probability of u1 divided by probability of r when u1 r by u1. That means we have to 3, since there are 3 urn, since there are 3 urn, this is why you have to sum all the conditional probability. Since there are 3 urns are likely to be selected, probability of E1, probability of E2, probability of E3 equal to 1 by 3. Remember it. We have to select only 1 urn, but there are total 3 urn. This is why selection probability will be 1 by 3. Now probability of red ball when it comes from U1, a red ball is drawn from first turn equals to, in first turn there are 6 red ball and total ball 10. Similarly, it comes from, it drawn from second, red ball drawn from second turn equals to, in second turn there are only 4 red ball, in second turn 4 red ball, but total ball 10. This is by 4 by 10. And if the red ball is drawn from third turn, in third turn 5 red ball only 5 red ball. This is why, but total ball 10, 5 by 10. Now putting the all values in the Bayes formula, we get equation 1, we get the required 2 by 5. That means this is the probability of a red ball is drawn from first turn. Probability of drawn from first turn when the ball is red equals to 2 by 5. This example, in a bolt factory, that means an industry of iron. The bolt factory machines A, B, and C manufactures respectively 25%, 35%, and 40% of the total. That means total 100%. Machine A 25%, machine B 35%, and machine C 45% manufactures. If their output 5, 4, and 2% are defective bolts, if their output 5, 4, and 2% are defective bolts, a bolt is drawn at random from the product and is found found to be defective. What is the probability that it was manufactured by machine B? That means it must be a defective and it comes from second machine, that means B machine. We have to find out this using Bayes theorem. Now let consider A is the event. Bolt is manufactured by machine A, and B for bolt is manufactured by machine B, and C bolt is manufactured by machine C. Now probability of A 25%, this is why 0.25, and probability of B machine 35%, this is why 0.35, and probability of C 0.40%. Remember, total probability 100%, that means 1. Probability 1. Probability 1 for sure events. The probability is drawing a defective bolt manufactured by machine A. Defective bolt by machine A, that means it is defective. It is defective, but it drawn from machine A. This is the probability of D by A. Probability of D by A means what? Probability of defective, but it comes from machine A. This is the 5%. Similarly, probability of defective, it comes from machine B, 4%. 4% means 0.04, and probability of defective, but it comes from machine C, this is the 2%, 0.02%. This is the all the values are given in the question. Now from Bayes theorem, we get probability of machine B when it is defective. If it is defective, then it comes from machine B. This is the probability of B by D equals to probability of B, probability of D by B. Then there are 3, how many machines? First machine, second machine, third machine. But it comes from machine B when it is defective. Remember it. Probability of defective যেটা হচ্ছে সেটা মেশিন বি থেকে আসতেছে, ঠিক আছে, ডিফেক্টিভ হবে বাট মেশিন বি থেকে আসতেছে। দিস ইজ কল্ড probability of machine B when a bolt is defective. Just putting the values. Clear? Bayes theorem এর প্রমাণটা একটু শিখবে। Bayes theorem and other proof, তোমরা চাইলে এটাও কিন্তু শেষ করতে পারো। Bayes theorem এর স্টেটমেন্ট প্রুফ, যেটা ভালো লাগে সেটাই করবে। এখানে কিছু রিমার্কস অন Bayes theorem. Bayes theorem for future events. Future events, probability of C when A is happened equals to summation I equals to 1 to n probability of EI. Just এটা ইনভার্স Bayes theorem. এটা আগে নিচে ছিল, এখন উপরে গেছে, আর উপরেরটা নিচে গেছে। এটা ফিউচার, এটা প্রুফও আছে, তোমরা চাইলে প্রুফটাও শিখতে পারো। সেম প্রসেস। Okay, now another example of Bayes theorem. In 1989, there were 3 candidates for position of principal: Mr. Chatterjee, Mr. Ayanagor, and Dr. Singh, whose chances of getting appointment in the proportion 4 to 3 respectively. That means there are 3 candidates. First candidate 4%, second candidate 2%, and third candidate 3%. The probability that Mr. Chatterjee, if selected, would be introduced to co-education in the college is 0.3%. The probability of Mr. Ayanagor and Dr. Singh doing the same are respectively 0.5 and 0.8%. What is the probability that there was co-education in the college in 1990? Let there are events, 3 events, and probabilities are defined as follows. A is the introduction of co-education, and E1 is the Chatterjee is selected as principal, E2 for another candidate Ayanagor selected as principal, and E3 for Dr. Singh selected as principal. Now probability of E1, probability of E2, probability of E3, this is given total proportion what? 4 plus 2 plus 3 what? 9. But for E1 4 by 9, since proportion 4 and total proportion they divide. Probability of E2 2 by 9, since for proportion 2 and total proportion divided by 9. Now third one, proportion is 3, but total proportion what? 4 plus 2 plus 3 divided by 9 total. Favorable space divided by total space. This is the probability. Now probability of A when E1 is happened. That means this is the 0.3 probability. 0.3 means what? Out of 10 he got 3. Out of 10 he got 3. This is why 3 by 10. This probability given. 0.3 means what? 3 by 10. And probability of A2 for A2 E2 5 by 10, and for E3 probability of A, if E3 is happened, then 8 by 10, 0.8. This is why. Now probability of A equals to probability of A intersection E1 union A intersection E2 union A intersection E3 total probability. Just putting the conditional probability formula. A intersection E1 equals to what? Probability of E1 multiply probability of A by E1. Probability of A when E1 is happened, plus this is the also conditional probability using first theorem, conditional probability theorem. Probability of E2 into probability of A when E2 is happened, plus probability of E3 when into probability of A when E3 is happened. Just putting the values of this. We have the values from the question. This is the result. The contents of urn 1, 2, 3 are as follows. One contains 1 white, 2 black, and 3 red balls. 2 white, 1 ball, and 1 red balls. And third one, 4 white, 5 balls, and 3 red balls. One urn is chosen at random and 2 balls drawn. They happen to be white and red. 2 ball is drawn and it will be white, and one is white and red. What is the probability that they come from 1, 2, or 3? We have to find out 3 result. It come from 1 or 2 or 3. Now let us consider E1, E2, and E3 denote the events that earn 1, 2, and 3 are chosen respectively. That means E1 for earn 1, and E2 for earn 2, and E3 for earn 3. Let A be the events that the two balls taken from the selected earn, which are white and red. Then probability of E1, probability of E2, probability of E3. That means the probability of earn selection will be 1 by 3, because we have to select one earn, but there are total earn 3. This is why probability will be 1 by 3. Now probability of A when it comes from first term, that means A by U1 equals to in 1 into 3, 6 to 3. That means in first earn, how many balls in first earn? In first earn, how many balls here? 3 red ball, right? 3 red ball. In first, 3 red ball. That means 1 from 3, 1 ball from 3. Uh, that means 1 multiply 3. Then E1. In E1, total ball what? Total ball 6. And from total ball 6, we have to drawn 2 balls. That means 6E2 equals to 1 by 5. Similarly, probability of A by E2. Now number of probability in second ball, uh, white how many? 2. 2 multiply red how many? Red 1. This is 1. And total ball what? 4. And 4. So drawing 2 balls from 4 balls, 4C2. This equals to 1 by 3. Just combination formula. Now and from probability of A means what? Probability of A means drawing 2 balls from selected R, which are white and red. Remember it. Probability of A when it comes from earn 3. That means in earns 3, white ball 4 multiply red ball how many? 3. This one 4 multiply 3. Total favorable sample. Now total ball what? Total ball 4 plus 5 plus 3. That means 12 balls. From 12 balls we have to draw. We have drawn 2 balls. This is why 12C2. And after calculation 2 by 11. Now probability of second arm when when drawn the 2 balls, one is red and other is white, will be Bayes theorem. This is the Bayes theorem. Probability of E2, probability of A by E2. That means I equals to 1 to 3. I equals to 1 to 3. That means probability of E1, this same E1 EI, probability of A by EI. Putting the values, and this is the 3 term. That means E1 A by E1 plus PE2, probability of A by E2 plus probability of E3 plus probability of E3 into probability of A by E3. That means there are 3 terms. Total calculation this. Similarly, probability of E2, it comes from E2. That means second arm when 2 balls drawn, one is red and other is white. Similarly, second E2. This is what? E2, and this is what? E3. E3 similar formula you have to use here. And this is for R1. R1 will be what? Total probability 1. But if we subtract this probability and this probability, then it will represent the probability of third arm. Just taking minus. Or any other way we can use this formula also. Example আমরা করছি. This is left for your homework. 4.32 example, this left for you. এটা তোমরা নিজেরা করে নেবে. Similarly, a bolt factory, এটা করে নেবে, হোমওয়ার্ক থাকবে. The state and prove Bayes theorem, very important for you. State and prove Bayes theorem, and the application of Bayes theorem, most important for you. This is the whole exercise. Suppose this is the review example review class. Two dice, one green and other red are drawn. Two dice, one green and other red are drawn. Let A be the events that the sum of the points on the faces shown is odd. Odd means you must know 1, 3, 5, 7, etc. And B be the event at least one is number 1. Now describe the number 1 question. Complete the sample space. We have to find out the complete sample space. Number 2, we have to find out in 2 events A, B and B complement. That means B will not happen. A intersection B, that means A and B will happen conjugately. A union B, that means A will happen and or B will happen. A or B. A and B will not happen. Find their probabilities that all the 36 sample points have equal probabilities. Number B, find the probabilities of the events. In number 1, a complement of A union complement of B. That means A will not happen or B will not happen. A will not happen intersection, B will not happen. A event A will happen intersection, B will not happen. A not happen intersection, B happen. That means we have to find out this whole probability. At last, B will not happen if A is not happen. This is the probability. Now the sample space consists of 36 elementary elements because in one dice there are 6 sample spaces. This is why in 2 dice there will be 36 events. That means in first dice 1 may come, in and second dice 1 may come. One in first dice 1, in second dice 2, in first dice 1, in second dice 3. In this way we get 36 sample space. Where for example the ordered pair 4, 5 refers to the elementary event that the green die shows 4 and the red die shows 5. Green, first one is green and second one is red die shows 5. Now A equals to the event that the sum of the number shown by the 2 dice is odd. 2 dice is odd. That means sum of the number shown by the 2 dice is odd. 1 plus 2 what? 3. This is odd. 2 plus 1, this is odd. 1 plus 4 also odd. That means odd event or odd sample space. You have to. That means this one odd, this one odd. Similarly, this one 2, 3 is also 2, 5. That means how many sample space are odd? Sum of odd. How many? Maybe 18. 1, 2, 3 up to 18. And therefore probability of A will be favorable space what? 18 divided by total sample space 36. 18 by 36. Again, now B equals to the event that at least one face is 1. The event at least one face is 1. That means in 1, first dice 1, second dice 1, first dice 1, second dice other, first dice 1, first dice 1, first dice 1, first dice 1, second 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 dice 1. That means at least 1 comes in any dice. Therefore, the probability of B favorable how many? 1, 2, 3 up to 11. That means 11 divided by 36. Now, complement of B, that means without this sample space, without this 11 events, the events that each of the face obtained not in S. Without this 11, how many left? 25. 25. That means after removing this sample space from the whole sample space, we get another 25, which will be not happen B, not phase. The event that each of the phase obtained is not an edge will be this 25 sample space. So probability of this will be favorable 25 samples divided by 36 total sample. Now A intersection B will be A intersection B what? Common sample space. A will be the this 18 samples and B will be the this 11 samples. Now common samples what? Here 1 to common. Then 1 1 6 common, right? In this way, A intersection B will be this 6. The event that sum is odd and at least one phase is an edge. That means these 6 samples are A intersection B common, both happening in A also, happening in B also. That means this 6 divided by total sample space what? 36. Similarly, A union B, that means happening in A or all the sample space of A or all the sample space of B. That means taking all L together, we get 23 sample space. A and B, A and B. Union, just taking union. Union means what? All will be the sum of all sample space. The sum of all sample space will be 23 divided by 36. Now again, A intersection B is not happened. A intersection B is not happened. B is not happened. This is one. That means 25. This 25 sample space and A. Taking common of this 18 and this 25. Common. How many? Common will be this 12 sample space. Just taking this 12 probability of A intersection, probability of not B, which is not happening. Total will be 12. Number of total sample space will be 36, 1 by 3. Now another section, in the another section B, probability of A complement union B complement. That means not will happen A, not will happen, or not will happen in B. That means probability of A intersection B altogether, right, equals to 1 minus probability of A intersection B. We have found A intersection B equal to 1 by 6. That means 1 minus 1 by 6 equal to 5 by 6. Similar case, we use A complement intersection B complement equal to probability of A union B complement total. That means 1 minus universal set means what? Total probability 1. 1 minus A union B, probability of A union B. Probability of A union B we found 23 by 36. Just putting the values all, we get this one. Probability of A by B, this is the conditional probability using conditional probability formula. Okay, this will be the homework for you. Try at home. I hope everybody will understand this. Important example for you. Now, in the following figure, there are figure A and figure B. Assume that the probability of a relay being closed is P and that a relay is open or closed independently of any other. In each case, find the probability that current flows from L to R. That means from L to R, current is flowing. From L starting current, then ending to R. Now solution, let AI denote the events that the relay I depend on AI. I equals to 1 to 6. I equals to 1 to 6. How many? There are resistance. How many? Resistance 1, 2, 3, 4, 5, 6. This I depend on this 6. Is closed and E be the event that current flows from L to R. L to R. Current flowing. Now in figure A, the current will flow from L to R. From L to R. If at least one of the circuits from L to R is closed. At least one is closed, then current will be flowed. Thus, for the current to flow from L to R, we have the following favorable cases. First one, A1 intersection A2 equals to B1, or in second, in A4 intersection A5 equals to B2, and A1 intersection A2 intersection at A1 intersection A3 intersection A5. That means all odd, B3 and A4 A3 A2 equal to B4. This one A1 A2 A1 A2 from this resistant A1 A2, then A1 A4 A5, then A4 A5. This is the another. This is a way. One is way one A1 A2 in this way L2R, and L2 at another way A4 A5, right? Then A1 A3 A5, A1 A1 A3 A1 A3 A5. This is the another way to get B3. A4 A3 A2, A4 A3 A2. This is the way to get B3. Now the probability P1 that current flows from L to R is given by P1 equals to probability of B1 B2 B3 B4 equals to summation probability of BI union formula minus probability of BI minus probability of summation I less than Z probability of BI intersection BJ plus probability of if Z lies between IK probability of BI intersection BJ intersection BK minus all intersection B1 to B4. Since the relays operate independently of each other, we have probability of B1 equals to probability of B1 means A1 intersection A2, and B2 means A4 intersection A5, and B3 means this three A1 A3 A5. All are P. This is why P square P. This also P square below P. 3 from multiplicative law of probability. Probability of A1, probability of A3, probability of A5, P cube. This is also P cube. Similarly, probability of B1 intersection B2 equals to probability of all A1 to A5 intersection A to A. This equals to multiplication. Intersection means multiplication. P4. This also B1, B2, B3. These three B1, B1, B3, B1, B2, B3 intersection. That means A1, A2, A3, A4, A5. A1, A2, A3, A4, A5, P5, and so on. Finally, substituting in equation, this equation 1. Equation 1, putting all the values, we get the required probability P2 equals to. একটু কমপ্লেক্স আছে, আমাদের আগে একটু সার্কিট থেকে ভ্যালুগুলা বের করা শিখতে হবে। The following figure A and B. This is the first figure A and this is the second figure B. Assume that the probability of a relay being closed is P and a relay is open or closed independently of any other. In each case, find the probability that current flows from L to R. L থেকে R এর দিকে ইলেকট্রিসিটি যাবে। হ্যাঁ, এটা